So in this video, I'm going to go over Bubblesort, which is a sorting algorithm that you may or may not have learned by this point. This is a pretty good explanation over here, so you can go and simply look for just look on YouTube for Bubblesort and look at the HackerRank video for that. But I'm going to go ahead and explain it anyway here, or you can skip forward to where I actually start coding it if you already know it. So Bubblesort is sorting. Let's go ahead and just define that. That's the objective of sorting is putting things from the smallest item to the largest item, putting the items in ascending order. We're going to typically do this on numbers simply because single-digit numbers are very small and easy to sort. Small in the sense that they don't take much teaching space up, right? So let's go ahead and take a look at this array of numbers that I'm writing down. Let's go ahead, 8, 7, and then 5. All right, so the way Bubblesort works is fairly straightforward, right? We want to get this in order. And the way Bubblesort works is that we just go through the array checking adjacent pairs of items. So first I'm going to check 4 and 2. And I ask a very simple question. Are these two items in order or out of order? 4 and 2, we want to put this in ascending order. So the 2 comes before the 4. They're out of order. So I swap 4 and 2. Okay, then I go on. So this pair of items is now sorted. But now I go on to the next pair of items. 4 and 1. That's also out of order. So I will simply swap that. 4 and 3. That's out of order. So I will swap that. 4 and 8. That's in order. So that stays put. 8 and 3. So 3 and 8 swap. 8 and 7. 8 will swap with 7. And now 8 and 5. 8 will need to swap with 5. And now we got into the end. And it is actually slightly better sorted now. But the reason it's called Bubblesort is because the biggest item in the array will bubble its way to the top just by the virtue of how this algorithm works. We do enough, and then we just keep doing this again and again until it's sorted. 2 and 1, out of order. 2 and 3 are in order. 3 and 4 are in order. How did I get another 3 in there? I'm going to assume that's a 6. Let me go ahead. Actually, let me go and undo this. Oh, I just simply had a duplicate 3 in there. Redo. Yep, I just simply had another 3 in there. Silly me. No worries there. It works just as well with a second 3, so I'm not going to do it. 4 and 3. That's out of order. Swap them. 4 and 7. 7 and 5. Swap them. Largest item bubbled to the top. And notice, 2 passes was all it took to get in order. Wonderful algorithm. Wonderfully simple. Okay, but to tell that we're sorted, we do a final pass. 1 and 2, 2 and 3, 3 and 3, 3 and 4, 4 and 5, 5 and 7, 7 and 8. We didn't do any swaps, so we know we're done. Okay. There's some optimizations we can make, but that's about it. One simple way we can do this is that we can check 1 and 2. We can just simply check all pairs, right? Well, that's not an optimization. That's the simple way to implement it. So let's go ahead and start implementing it. So first off, I need to do something a bit different here. In order to sort stuff, public static void Bubblesort. In order to sort things, I have to actually, be sure that the list of stuff I'm taking in can be sorted. So the list of, I'm going to use T here because that's the convention. List. It's not enough for me to say that T is a generic type over here, right? Because T's can be anything. They can be scanners, but I don't know about you, but I have no idea how to put a scanner in any sort of order, right? Which one comes first? Which one comes second? I don't know. So things, in order to be sorted, they have to be orderable. They have to be able to put in an order. So in Java, the way we handle that is that we have a class called comparable. It's an interface called comparable. And basically anything that can be compared against one another to say this comes first versus this comes last is a comparable. So integers are all comparable. Doubles are all comparables. Strings are comparable. They compare to check alphabetical order. And what it will do is that, well, I'll show you. So first off, to declare that everything is comparable, we use extends over here, comparable t. So this whole thing looks very scary and confusing, but all this is saying is that every t that's in here, every t that I'm using, every list that I'm taking in, the items inside the list have to be of type comparable. And what do they compare to? They compare to other t's. They compare to each other, right? It's not ints to doubles or doubles to ints. It's ints to ints or strings to strings, right? That seems like a really weird definition, but roll with it. Now, once you have these, I can simply say that, let's see, t item is equal to list.get 0. Just needed to grab one. And now I know that item is a comparable as well, and it has this new method called compare to. And I will just simply use this and then compare to, control Q, compare to, compares this object to the specified object, right? It will take in another item. So item compared to other item, whatever that is, right? And what it will do is that this is a bunch of stuff, but it's going to return a negative number. It's going to return an integer, negative number, 0, or positive integer. So let's just go ahead and just call this A and B. If A comes before B, then it will return a negative number. If A comes before B, it returns a negative number. If A comes after B, it will return a positive number. And if A and B are equal, it will return a 0. So we'll see how to use this now. Okay, so that seems weird, but no worries. So let's go ahead and write Bubblesort. So for int I is equal to 0, I is less than, for int I is equal to 0, I is less than, list dot size minus 1. And so I'm going to be a bit weird and write the inner loop first, because that's just a bit easier for me to just simply go through. I'm going to compare 1 to 2, right? The part where we just do one iteration where we compare all pairs. So t left is equal to list dot get I t dot t right is equal to list dot get the one right over, I plus 1. And then if how do I tell if they're out of order? So I'm going to go ahead and actually, because of time constraints, I'm going to skip to the more optimized version of writing this, which will requires no changes on my part. So if list dot get, if left dot compare to right is greater than 0, right? So what am I saying here, right? Left and right, we would ideally be in order, which means that left would be less than right, which means that left compared to right would return a negative number. Or if they're the same value, like 3 and 3, they'll return a 0. So if it's greater than 0, left compared to right, that means they're out of order. Left is bigger than right. So in that case, we need to swap them. Right? I'm going to go ahead and actually just kind of just demonstrate in case you're curious. JShell integer I is equal to 7 I dot compare to, is it capitalized? Yes, capitalized. Compared to 8 turns to -1. 7 dot compare to 10, -1. Right, should come first. Right, I is smaller than 7, I is smaller than 8. Compared to 6 will return 1 because I is bigger than 6. That's the way it works. I do hello dot compare to world, right? Hello comes before world, so that should be a negative number. In fact, it gives me -15. Why -15? It just happens to actually deal with some distance, right? So this actually gives you some information. It doesn't have to be 1 or -1 or 0. So anyway, left dot compare to right. If it's bigger, will return. If left is bigger, so if we get something like 5 and 2, right? If left dot compare to right, 5 is greater than 2, then that will return 1. So we need to swap them as a result. We need to swap those locations. So what we can do is fairly straightforward. We will simply say, and unlike swapping stuff with arrays, we can actually do this in 2 lines thanks to the set method. So t old is equal to list.set. Set the ith element in the list to the right. Oh, I've already saved them, so actually I don't even have to do this. Set the list.set I to the right element, right? Left was I, and list.set I plus 1 to the left element. So we just simply swap them and replace them, right, using the set function. I don't need a temporary variable over here because I already have 2 of them. All right. And so now, how many times do I have to run this loop, which will run n-1 times, which is close enough to n, right, for us to be going on with. How long does this take? How many times do we have to do this? Well, the optimal way to do this is that, right, it took us only 2 run-throughs to get this sorted. So, since the largest item bubbles up each time, I could totally do an outer loop that simply ran this n-1, that simply ran this loop n-1 times. 8 would bubble up, then 7, then 6, then 5, then 4, then 3, then 3, then 2, then 1, assuming that it's in the absolutely worst case scenario where basically it's in reverse order. More on that in the module on sorting about like the worst case scenarios for each of this, but suffice to say basically that that running this loop n-1 times would guarantee that it would be sorted no matter what. But sometimes we can just stop early. So we can do that. So worst case scenario, by the way, was running this n-1 loop n-1 times, which is still, if you multiply that together, gives you an O of n, which gives you n squared in the T of n, which means that it will take O of n squared time, right? Still that quadratic relationship. So what we're going to do is we are going to check to see that it is, we're going to do this basic check. So we're going to do a Boolean swapped is equal to true. While swapped, so while that swapped variable is true, I am going to go ahead and notice I love IDEs. They'll automatically indent for you like that. So while swapped is true, I'm going to set swapped to false. And basically I'm going to say, I'm using this to keep track of, have I swapped something this iteration? And if I don't swap anything this iteration, that means it's completely sorted, so I don't need to do anything. But if I do something over here and say, if I do swap stuff over here, then it's not in order, so I'm going to just say swapped is equal to true. So if I swap things, I set swap back to true, which means that By the way, you might have to double check it next time around because it wasn't sorted this time around, so it may not be sorted next time around. So this should work. So let's go ahead, and what we're going to do is that we are going to add a bunch of random numbers first to our list. So list.add, let's go ahead and create a new random number generator. Random R is equal to new random. So this creates pseudo-random numbers for us, not pure random. That gets into a whole debate whether things can actually be random or is the universe completely deterministic, right? Go and talk to a philosopher about randomness, and he can probably go on for hours and hours. But suffice to say, we are statistically random over here. So we're going to go ahead and add r.nextInt, which will add a random integer from any range. Add 1,000 of those, and now what we are going to do is that we are going to bubble sort that. We'll print out the time, and we'll print out our list to show that it's got sorted. Right, so notice that we've got all these negative numbers, and they get slowly bigger, so to speak. And then they get like that. Let's see. Is there a way to do r.nextInt? R.nextInt bound. So let's go ahead and just Control Q. Uniformly distributed 0 and that value. Great. So what I can do over here is simply say I want these numbers from 0 to 1,000,000. So now that will be a bit easier for us to read. Right? Now if I do 10,000 items, right? Again, so that took about 100 times longer. Or sorry, 10 times longer over there right now. Now if we do this, it takes significantly longer. Because again, we got to that point where basically that we're actually having to spend computation to do it. Sorting isn't really a hard task, but going from 10,000 to 100,000 using a sorting algorithm like this takes a long time. Let's go ahead and try. So we're at 10,000, right? So now let's go ahead and go up to 20,000. So that 4 times 4 relationship is still there. This is a quadratic sorting algorithm. So, but again, knowing the proper algorithms can help you. For instance, using the collections.sort, right? That will use a different sorting algorithm, and it does that no problem. It will use, let's see, what does it use? I think it either uses quicksort or timsort, depending on what it is. But that algorithm is not O of n squared. It's a much quicker algorithm.